today we're going to do the gut microbiome, and it's a really nice introduction to understanding gut health today. So we're going to have an insight into what's covered in our gut and microbiome short course. And this short course is actually a foundation unit of study in our Women's Health and Wellness Coach certification. So if you've been considering this program at all, then you're going to get a nice overview tonight of the kinds of things we cover in the course. And this is what we're going to run through this evening. So the gut physiology and function, the microbiome, the body, the mind and the gut, and then also nurturing a healthy gut. So a bit of gut health how-to. Okay, so we'll kick off with a little bit of an introduction to the actual gastrointestinal system. So the gut is also known as the gastrointestinal tract. It's the entire digestive system, so consisting of the mouth, the esophagus, the stomach, the small and large intestine, the rectum, and the anus. And so this is a nice little graphic here. So it's actually a little bit like a donut. So it's open to the environment, running all the way from our mouth and all the way down here, incorporating all of those organs. We've also got some complementary organs that help digesting food. So the liver, gallbladder, and pancreas. The mouth is where our food digestion begins, and it includes the teeth, tongue, salivary glands, and the breakdown of food actually occurs both mechanically and chemically here. So the mechanical chewing of our food is a process called mastication, and it breaks food down into smaller pieces with a greater surface area. So when we chew, our food is actually mixed with saliva, and this is secreted from the salivary glands. And this is where the chemical breakdown begins. So with the salivary enzymes released into the mouth, they get to work too. Enzymes are proteins. They act as catalysts for chemical reactions in that they really help things by speeding up the chemical reactions within our body. There are enzymes in saliva that work to break down starches, and others for fats and others for proteins. And what they're doing is breaking food down into, from its complex structure into more smaller digestible constituents, so that as it moves through the gut, it's in a more digestible form for our other gut organs. The esophagus is a muscular tube that carries food from the mouth to our stomach, and our partly digested food moves down the esophagus in a wave-like motion. It's called peristalsis. And then when it's ready, it moves into the stomach. And our stomach is a bit like a balloon. So it stretches and retracts when we eat and drink. When it's empty, it holds around 50 ml of water. So it becomes quite small, but when stretched, it can essentially stretch up to 1 to 2 liters in capacity. We have an elastic structure called a sphincter at each end of the stomach, and this prevents food from moving in the wrong direction. So the lower esophageal sphincter here, or the LES, stops food from moving back up the stomach into the esophagus. And you'll likely have heard of this as reflux or heartburn. So GERD, or gastroesophageal reflux disease, is a chronic case of reflux, and you'll see what this looks like in the image on the screen here actually. So over on the right, the LES is open, the esophageal sphincter here is open, and this allows for gases and sometimes fluid to move upwards. And then due to the acidic nature of the stomach, this can be really uncomfortable for people that suffer from this condition. The stomach acid can also wear away at this sphincter here, and that makes people more prone to reflux more often. And then down at this bottom end, we've got the pyloric sphincter, and this stops food from moving the stomach for the small intestine before it's been digested enough. So in the stomach, we've got glands here, and they secrete digestive or gastric juices that further help to break down this food. And these juices will include things like water, enzymes, and then also the superacidic hydrochloric acid, or HCl. So the acidic stomach environment, it actually serves a few purposes. One is not only to chemically digest and kind of continue breaking down those strong compounds in our food, like proteins, but also to kill any harmful bacteria that we've ingested as well. So it helps us from getting sick. So as we have 3 macronutrients, which are our carbohydrates, proteins, and fats, there's actually 3 main groups of digestive enzymes as well. So amylases, lipases, and proteases. And I thought we'd look at a really common example here for those that experience digestive conditions like lactose intolerance. So in this case, it's actually the condition is to do with the enzymes. In lactose intolerance, the body isn't producing enough lactase, which is the enzyme that's required to break down the carbohydrates in milk. There are lots of digestive enzyme supplements available to help with digestion, and these can come from both animal and plant origins. And then going back to our lactose example, you probably have noticed that there are some lactose-free cow's milks on supermarket shelves now. But if you actually check the ingredients, you'll notice that the product isn't free from lactose, but just includes the enzyme lactase, so that the lactose can be digested easily. And then when it comes to dairy and lactose, the degree of indigestibility can actually vary from person to person, of course, but it also varies depending on the product. So a lot of people that can't digest cow's milk, for example, can actually digest Greek yogurt completely fine. And that's to do with the bacteria in yogurt, which is already working to break down some of the sugars, which will be lactose in the case of dairy, before we've even eaten it and begun to digest it ourselves. Many people also have problems digesting proteins, and so supplemental proteases, the enzyme for protein, are really common too. They break down protein into peptide chains and then into individual amino acids, and these are common in lots of plant foods. So pineapple and papaya particularly have a strong proteolytic effect, as well as some fermented foods like sauerkraut, miso, and kefir. Okay, so the small intestine, this is a curled up tube of about 6 to 7 meters long when it's laid out flat, and digestion continues here, and food continues to be moved through by muscular contractions. So the lining of the small intestine is covered in finger-like structures called villi, and they're covered in microvilli. So they're projections like this, and each of them is covered in a bunch of other, little finger-like projections. And essentially this increases the surface area of the small intestine so that our ability to absorb nutrients is also increased. Macronutrients, so carbohydrates, proteins, and fats, as well as water and vitamins and minerals, are all absorbed here in the small intestine. Now, this is pretty clever. When food reaches the small intestine, it's actually super acidic from being in the stomach. And so to become more neutral, which is necessary for the small intestine to absorb the nutrients, our pancreatic juices that are released from the intestine actually contain sodium bicarbonate. And sodium bicarbonate is alkaline. So this neutralizes the food that's come through and brings the environment to a more neutral setting. And then we move through to the large intestine. So this basically just picks up where the small intestine ends, includes everything from there through to the anus. And what's remaining by the time we reach the large intestine is undigested food. It stays here for kind of between 4 and up to 72 hours, where the mass has been quite watery before. The water is absorbed here and a semi-solid stool is formed, and then it exits the body. Okay, so now we're actually going to look at the microbiome. And this is a really highly researched area at the moment. And even knowing as much as we do, gut research is still in its early stages. So these are the things that we're going to look at here. What is the microbiome? What its function is? How we build a microbiome? And then a healthy gut, what that actually looks like. Okay, so what is the microbiome? It refers actually to the collection of microorganisms that live in and on our bodies. The gut microbiome is therefore the microorganisms that are located in the gut. Microbiota are the types of microorganisms in our community. So our microbiome is comprised of microbiota. And when you hear microbiota diversity, it's referring to all the different species in an environment like the gut. A healthy gut's going to have more diversity. Reduced diversity can indicate dysbiosis, which is an unbalance. And this is related to several disease states. The gut microbiome is made predominantly up of bacteria, but also some viruses, fungi, archaea, and eukaryotes. And most live in our large intestine, and then a lesser amount and a lesser diversity as well in our stomach and small intestine. And this is actually related to the acidity of those latter environments. It isn't ideal for most of these microorganisms. So the microorganisms that live in our microbiome, like bacteria, like viruses, they're not pathogenic or harmful. Rather, they actually benefit us in many ways. And when we're talking about how many, there's actually trillions. So that's why you'll see probiotic foods, drinks, yogurts, for example, they talk about bacteria in the millions or billions. And then this image here, it actually just looks at what the types of bacteria are, but also where they are in the body. So you'll see that the colon, which is part of the large intestine, has the largest diversity and actually the largest numbers as well. So it's a huge microbiome here, but we've also got microbiome on our skin, mouth, up in the esophagus, and then in the vagina as well. The gut microbiota it's really important in health and disease, and we can see that on the image here. We move from a state of disease into a state of health, and it is spectrum based. But if you can see there on your screen, it is a little bit small. What's happening in the healthy, when we're in health, we've got lots of production of short chain fatty acids, which are metabolites of fermentation in the gut. Low gut inflammation, insulin sensitivities at an optimal rate. But then over here, when we're in a state of disease, the gut's influenced quite strongly as well. So one key function of the microbiota is manufacturing essential vitamins, so such as vitamin K. We need this for blood clotting, and then also vitamin B12, which we need for red blood cell formation. Immunity in the gut. Our microbiota has a huge influence on our immunity. Our immune systems help us to fight disease caused by harmful pathogens. And we have two immune systems. One is innate, and this is our immunity that exists at birth. It's our first line of defense, and part of this is our microbiome that's passed on to us from our mother, so from mother to baby at birth. And then the other is acquired immunity. So this is the immunity that we develop from exposure to pathogens, and it's adaptive to our conditions as we grow. Our microbiota support the development and functioning of our immunity by slowly training our immune system to tolerate microorganisms like bacteria and viruses, and then respond appropriately to harmful ones. So we established this really lovely codependent relationship with our intestinal microbiota within the first 3 years of our life. And where we used to think that the colonization, they called it, of the gut microbiome started when we were born, we now know that actually starts before birth. So the fetus takes on some of the mother's microbiome in utero. And therefore this process is influenced by things like the mother's own microbiome, the mother's diet and lifestyle, their use of antibiotics, stress, but also the most significant influence on our gut microbiome through infancy is birth. So if you can recall from a few slides back that women have a vaginal microbiome. So for babies that are born through the vaginal canal, they'll come into contact with this rich microbial environment when they're born, and they're inoculated with their mother's microbiota, and then their own gut microbiome will end up resembling this. Babies that are born via cesarean will have a different microbiome. It more resembles that of the mother's skin rather than vagina, but the types and variety in the bacteria, the types and variety of bacteria in the infant's microbiome will be different between vaginal and C-section babies, but they'll become more similar over time as they grow and develop. After birth, babies that are breastfed will have further exposure to the mother's microbiota. And then as all babies begin to interact with their environment, the acquired immunity begins to kick in with further exposure to microbes. Okay, so healthy microbiome, what does it look like? This is a really, really popular area of research. So we're looking to find out more about how an unhealthy gut microbiome can cause or is linked to various diseases. It's proposed, though, that a healthy microbiome will typically have the following 3 characteristics. So 1, it's going to be high in diversity, many different types of bacteria, viruses, etc., and the more types, the better. 2, it's mostly free of pathogenic organisms and substances that can cause infection and make us unwell. And then 3, resilience. So the microbiome can recover easily after infection or imbalance. Factors that affect the microbiome health status. 1 is medication. So antibiotic use. Antibiotics can kill, well, they kill all bacteria that they're exposed to, not just the harmful ones. So our healthy gut really gets hit hard when we have to take antibiotics. For most people, their microbiome will recover quickly, but for many, this can take weeks or even up to years. Another factor is diet. So long-term dietary habits can change the types of bacteria that we see. So the type of bacteria we see, for example, for someone that's on a high protein diet will be different to the types we see for someone on a high carbohydrate diet. And then, of course, lifestyle. So notably, smoking and alcohol intake have a strong influence. There are thousands of chemical compounds in cigarettes, and these have a toxic effect on the body, of course, but in terms of the gut, they decrease the diversity of the microbiota very significantly. And then alcohol can have a positive and negative effect, but as you can probably expect, it's a dose-response relationship here. So excessive drinking has a negative effect. Essentially, we and our microbiome really rely on each other. We give it a nice, nourishing home, and it promotes both our immune and digestive health and stops harmful bacteria from taking over. Okay, so we're going to have a look at the body, the mind, and the gut. And what we're going to do, we're going to look into some, not all because there's so many, but some of the health conditions that we experience and that are associated with gut health, and then also the gut-brain connection that you may have heard of. So we're going to cover celiac disease, SIBO, the gut-brain connection, and also gut and mental health. But in the course book for the gut health unit, the gut health course, you'll find a lot more information. We also cover stress. There's a lot more information on lactose intolerance as well, inflammation, hormone conditions, and a heap more. Okay, so celiac disease is a medical condition that affects people of every age. Like lactose intolerance, celiac disease is also associated with the villi that line the small intestine. So if you remember, they're those finger-like projections that line the entirety of the small intestine and help us to absorb nutrients. Celiac disease is an immune response by the body to gluten, and gluten is a protein. It's naturally present in some grains, wheat, barley, rye, and it gives grain foods like bread an elastic, chewy structure. So if you can kind of think that a gluten-free bread is typically not that bouncy or chewy, it's usually quite dense and crumbly, whereas say a wheat sourdough has that really nice chewy texture. It expands as it cooks, with heat and lots of air being able to get in the bread, so it's nice and fluffy and chewy. For people with celiac disease, when they eat gluten, the villi react and they become inflamed and become damaged, and over time they essentially flatten. So this image here on your screen shows healthy villi. So for somebody that doesn't experience celiac disease, the villi they're quite pronounced. They're standing up nice and tall, and there's lots of space here for nutrients to kind of access and become absorbed. Whereas in celiac disease, they've become flattened there's far less surface area, and the nutrients just kind of end up bouncing around looking for a site in which they can become absorbed. And they're fighting time essentially as well, because they do need to become absorbed before the food moves through to the large intestine. So this flattening over time, it's a problem because, yeah, essentially most of our nutrient absorption occurs here in the small intestine. Sufferers will therefore also experience gastrointestinal symptoms like diarrhea, constipation, bloating, and then fatigue, anemia, and then also potential micronutrient deficiencies from poor absorption. So as a medical condition, celiac disease, people do have a genetic predisposition to the condition, and it can manifest through childhood or later in life as well. Not all those with the genetic predisposition will develop it, but to test for celiac disease, we can do a few things. So one is, of course, to eliminate gluten from the diet and monitor, but this is really only indicative. And it's hard to tell sometimes whether it is gluten because an elimination diet like this doesn't really, it doesn't indicate between different food triggers. We can also do a blood test to look for elevated antibodies, which will be present after a reaction occurs. And then there's the small intestine biopsy, and this is the only way to get a confirmed diagnosis for celiac disease. Hope everyone's going okay. Have a sip of water. I know my throat's a bit dry. All right, so we're going to move on to SIBO. Lots of talk about SIBO in the kind of health media at the moment. So it stands for small intestinal bacterial overgrowth, and it occurs when the bacteria in the small intestine rapidly multiply in number. So symptoms will include bloating, abdominal pain, gas, constipation, diarrhea. And then this is a problem because you'll remember that the large intestine is where most of our bacteria should be. So when they're in our small intestine, they're interfering with the nutrient absorption there. And they're actually can be competing with our own bodies to be fed. We treat SIBO with antibiotics to reduce numbers, and then probiotics to relieve symptoms, and then dietary adjustments to starve the bacteria of any food so they stop growing in number. And then just on that, where it's, as a gastrointestinal condition causing bloating, pain, gas, constipation, or diarrhea, you'll recall that's pretty similar to celiac disease. It's also really similar to IBS, so irritable bowel disease. So with gastrointestinal conditions, it can be really quite frustrating for sufferers to figure out what it is they've got going on, what their triggers are, because the symptomology is really so similar between the conditions, but really varied as well. So yeah, it can be a long and grueling process. Okay, so seeing how intricately linked the gut is with aspects of our health, it's no surprise that the brain and our mental health are too. So with the gut health, our gut health actually influences our brain function, our mood, behavior, and more. We now know that there's actually a direct line of communication between the gut and the brain, and this is via the gut-brain axis. It's a bidirectional pathway, meaning that information is fed from gut to brain and then vice versa. And it involves multiple complex systems, so neurotransmitters, chemical compounds, immune pathways, hormone pathways, and a bunch more. And then our gut has its own nervous system too, our enteric nervous system. And this is essentially like our second brain, and it communicates directly with the brain in our head. So this little diagram here is just a nice little schematic of the gut-brain connection. So we've got the brain and our microbiome, which hosts trillions and trillions of microbiota. And then this is kind of like a highway, which is essentially run through our central nervous system, where information is fed back and forth constantly. How the gut influences our mental health is complex, and there's so many possible associations, but one example is with IBS, irritable bowel syndrome. So over 50% of IBS sufferers also will experience a mood disorder. And it's really, really common for antidepressants to be prescribed as part of IBS treatment. Depression and anxiety have been linked to a gut imbalance and gut inflammation, and as such, restoring a healthy gut has a potential role in the treatment and prevention of anxiety and depression. There's also a lot of research being done into gut dysbiosis and autism. Those with autism spectrum disorder commonly have GI issues. It's super common, gastrointestinal issues. And if you'd like to know more about this, the Mind Foundation has really great resources. That's MINDD. Okay, so we're going to look at nurturing a healthy gut. So practical ways to improve our microbiome diversity, variety, some functional foods, probiotics and prebiotics. So with gut conditions, there, of course, will be variations between people in how you manage your condition with diet. A healthy diet in general, though, should be high in variety, of high quality, wholesome, and meet individual needs, so tailored to your individual needs. Typically, though, diets that are high in fat, high in animal protein, and high in processed foods, and low in fiber and low in vitamins and minerals, will heavily reduce the amount and variety of healthy gut bacteria. And then unfortunately, this is pretty typical of the Western diet. The Mediterranean diet, which many of you would have heard about, a very, very popular topic in health and the purported health benefits of this style of eating. It's high in plant foods. There's less meat. There's very little dairy. Moderate alcohol, low to moderate alcohol, and then high in healthy plant fats. And it's also looking like it has a positive effect on our gut health. So as well as being really beneficial for heart disease and cancer prevention as well. This little image here, just comparing the Mediterranean and a typical Western diet. So what we've got is here, as we increase in these kinds of foods that are kind of processed, that's a takeaway container there. So, cakes, highly processed foods, we increase microbiota dysbiosis. So the microbiome or the bacteria in our gut is not able to remain in balance, essentially. It causes an imbalance, and then you'll recall it's associated with a bunch of different chronic health diseases. And then here, this is the Mediterranean diet on this side here. So what we've got at the top are very, very few of those processed foods, but moving down at this base here, lots of fruit and vegetables, lots of fresh food, and essentially what we end up with is symbiosis rather than dysbiosis. So the bacteria in our gut and us living in a comfortable way together, and in a way that's really promotive of health. Okay, functional foods. So you might have heard of these. There's no specific definition for functional foods, and it's something that's kind of toyed with a lot in the health industry. But when we're talking about functional foods, we're essentially referring to any food that is suggested to serve a function and have a provable benefit to human health beyond basic nutrition. So it's a huge industry. Think of all the foods on the market that are touted as having a health benefit, not only probiotic foods like kombuchas and yogurts, but also cholesterol lowering foods, the entire beauty food market, and so on. We won't go into them all, but we're going to look at probiotics and prebiotics. Okay, so probiotics are living bacteria. They are really beneficial to the gut. They have a proven specific health benefit. And then the most common probiotics we see are lactobacillus and bifidobacteria. And you'll actually see these listed in the ingredients list of probiotic food products. So if you flip it over, it'll tell you what culture essentially that your food contains, which bacterial culture, and then you should also be able to see the amount as well. So for a probiotic to work, it needs to first reach the large intestine without being destroyed through our digestive processes. And that's quite complex because you'll remember that it has to pass through the stomach, which is really very acidic. So probiotics need to be quite robust, quite strong. We have both food products and supplements for probiotics, and they're really quite widely available now in supermarkets and pharmacies. Supplements will come as capsules, powders, and liquid drinks. And when we purchase probiotic supplements, we should be taking note of the CFUs on the label. And this stands for colony forming units. A good guide is to choose a probiotic that has 1 million CFU at opening or above. So foods include probiotic drinks like kombucha, but most commonly we see fermented milk products, so yogurt, Yakult, kefir, and you can actually check the label for CFUs for your foods as well. And again, we're looking for a minimum of 100 million CFUs. Why so many? Research suggests that we get the benefits from probiotics at minimum 100 million. So 100 million up to 1 trillion CFUs per day. So 100 million would be the minimum that we look for. Okay, probiotics. So not to be confused with probiotics, slightly different. Very different actually. They're a type of dietary fiber, and dietary fiber is the non-digestible part of carbohydrate foods, so of fruit and vegetables typically, and then also some grains, legumes, and they actually feed and nourish our microbiota. So they feed probiotics as well that colonize the gut. So they not only feed the microbes in our gut that are already present, but the ones that maybe we would take as a probiotic drink, supplement, something like that, they also feed those and then allow them to colonize the gut and then really grow in number. Prebiotics need to survive the journey to the large intestine, of course. So they have to make it through the acidic stomach as well, and then also selectively interact with the healthy bacteria in the gut to improve and confer a health benefit. So selectively is the key word there. We don't essentially want them to feed harmful bacteria or pathogenic bacteria. We really want them to speak to and feed the ones that are going to promote our gut health. Okay, so these here are some examples of prebiotic foods. Jerusalem artichoke, super duper high. This chart here, it lists GOS and fructans, and they're the two types of prebiotics essentially. GOS is galacto-oligosaccharides, and then we've got fructans too. So naturally present in plant foods in varying amounts, but Jerusalem artichoke is super high in fructan. Some other really nice strong prebiotic foods are leek, beans, apple, rye bread, cashews, couscous, yeah, so some kind of pasta products as well, gnocchi, couscous, and yeah, custard apple, persimmon. So very varied, and you know, incorporating some of these foods into your regular diet will allow you to make sure that you're feeding the healthy bacteria in your gut. Okay, and then I wanted to just make a quick mention of postbiotics. So this is a fairly new term, and really only been popping up in the last couple of years. And essentially though, postbiotics are the byproducts or waste products of the fermentation process in our gut. And they also have a beneficial effect directly or indirectly. So they're not the live bacteria, and they're not the prebiotics that feed the live bacteria, but they're actually the byproducts of probiotics when they ferment or eat prebiotics or fiber in the gut. So it's essentially the waste, what it produces and what's left over. One example is short chain fatty acids, also includes enzymes, fragments of the cell wall that get broken down, and some vitamins and minerals too. But the short chain fatty acids are the byproduct of dietary fiber fermentation. And some of these byproducts are really effective actually at fighting inflammation. They can regulate gene expression, they can boost our immunity, and they can ease uncomfortable digestive symptoms. You can increase your postbiotic levels by upping your intake of prebiotic foods and probiotic foods, and of course by maintaining a diet high in variety of fruits and vegetables for lots of fiber. And this here is just kind of shows the cornerstones of a healthy microbiome. So we need prebiotics, probiotics, and postbiotics, all to hold up and support the microbiome essentially. Okay, so pretty much at the end, this is just some resources of where you can learn more about these sorts of topics. That was really, we ran through just a very brief overview there, and it really is such a large area. You can go into quite a lot of depth. So one option, of course, is the Gut and Microbiome short course that we offer. There's also a running project that's gone on for some time called the Human Genome Project. It's got some really great resources on genetics and the microbiome. Mind, I think I mentioned before, lots of info on different diets and gut conditions. They've got some great resources as well. And another is Microba. They offer microbiome testing actually. I think they only do the testing in Australia, but they've got some really great resources as well on things like gut diversity, microbiota diversity, what to look for. And if you were to get microbiome testing or something like that done, you can kind of see what that looks like, how many trillions you've got in this area versus that area. And they've got some really cool resources for and interactive ones as well for exploring that. Okay.